recently had a chance to talk to Jacob over at Spark Studio Salem makerspace, a local nonprofit, and of which I am a board member and Jacob's a board member of. And he was just running through a small project I thought would make a great demo to kind of get people to know what's up with CNC cutting. So without further ado, here's that clip. Hey Jacob, what's up with all the tape?
Getting set up to cut apart.
So what's this doing? What's this doing?
Using the tape and super glue method here. One of many ways to hold onto a part to ensure that you're not going to run into a clamp, run into another fixture, run into a metal screw in the middle of your part is if you put tape down on the top and the bottom, put super glue in between, hold your parts really securely without any lifting forces from a compression bit.
Aha.
It also means you got really good work holding no matter where you cut, and it gives you a little bit of extra thickness that ensures you're not going to cut into your spoil board.
The spoil boards are these rectangles you got on top of the table?
Yeah, so it's a strip here built up from the subsurface of the table. These are replaceable. We keep spares of these on hand, so that way as they get inevitably cut, as they inevitably get damaged, we try to avoid cutting into them whenever possible, but they are a bit of a sacrificial surface, and basically are a little bit like like a build plate of a 3D printer would be.
So while we're working our way through this, can you kind of say what the application difference is between this and a 3D print? Like it's a subtractive process to start with.
Correct, yeah. It's, in practice, realistically, you're talking about material selection here. You can't 3D print with just wood in a 3D printer. You can 3D print with wood-infused filaments and other neat things like that, but at the end of the day, you're stuck with plastic on a 3D printer. It's not everything. And having a machine of this format, you can cut large items, you can cut small items, you can cut items with different levels of detail, as well as different materials than what you'd be able to cut or produce on a 3D printer.
I believe this is a 28-inch...
32 by 34 active cutting area. They advertise it as a 30-inch by 30-inch machine.
Oh, what?
This is a CNC Labs, and that's spelled S-I-E-N-C-I, funny enough. They call it the LongMill Mark II. The LongMill Mark I was a really cool machine because it was pretty off the shelf. There was nothing realistically custom on the machine like this one is. This machine's got custom aluminum extrusions for the X and the Y axis that tends to make it stronger and makes it more customizable. This machine is a really budget machine in the world of desktop level CNC routers, and also industrial CNC routers. Most of your machines of this size category start at about $3,500 and go up from there. You're starting to talk industrial import machines. You're looking at easily $6,000+. These machines start in the sub $2,000 range and share different sizes. They're really, really capable little machines for what they are.
All right, done with the glue in there?
Yep, we're glued in, and we're gonna.
And what's the metal piece there you just put down?
It's a touch probe. So on big industrial CNC machines, you have a probe that goes into the spindle that is set up and trued on the axes of the machine. And a little machine like that, our main issue is we don't have repeatable tools. So if I put a tool in the spindle of the machine and I remove it, there's no way for me to guarantee that I've put it back in the same position. So, because of that, I need to ensure that I know where my workpiece is in reference to where the machine is. So I've written a custom probing subroutine, or a macro, that I have to manually bring the tool into the hole, and it allows me to...
So you're directing it there on the touch screen, saying, okay, move that thing?
Correct. It's called jogging, so I'm jogging the machine over into position. I do need to do a tool change here as well. This was a tool from a previous part we just cut. I might just do that here on the machine. And also, this is a palm router that uses standard 1/4-inch collets, and for using smaller tools, we end up using reducing sleeves as well.
So they can use different size tools?
Correct. Yeah, you can only run something smaller than the hole in the end of the spindle. You need to be able to clamp onto it.
Right.
So, for this cut, we're going to be using a tool with a 1/4-inch shank, which is exactly what the router is looking for. This is a solid carbide end mill. It's a 1/4 inch in diameter, and it's got a coating on it.
So you're taking it to the hole?
Correct. So the wiring here is for an inductive sensor, real similar to a multimeter. When you touch two probes together, it can beep to check continuity between 2 points. We're using it to our benefit here because we can leave the tool set up in the spindle, ready to go, and probe in exactly where the position of this part is.
So I noticed the hole is significantly bigger than the tool. So what are you looking at here?
Makerspaces. So the thing here is that
oh, you start with positioning the thing and then you move the block.
So what I'm doing is I'm doing a continuity check to ensure that the sensors are all set up and the machine is reading them properly. That way I don't go to start doing the macro and it starts moving and runs into itself without, it needs to know that the tool has touched. So that's just a test to ensure. And then here's the probing macro. It's going to touch all 4 sides of the part at varying speeds, record each of those numbers, and then drive to the center position and set my tool center.
Garden or something? I don't know what she's planning to do. Sure,
It's working.
Sure is. I normally run this twice.
And it averages them?
Yeah, so it's averaging every one of those touches and it's calculating the center position of the hole. And due to the geometry of this custom plate, the center of the hole that we've just touched off is the exact center point of the intersection between this wall plane and this wall plane. Because those two register along the portion of the part, you can assume that the center of the hole is perfectly centered around the tip of that part. Even if that part didn't have a tip, even if it was rounded over, you would still be able to approximate the position in which those planes intersect, which we've programmed into the computer as our 0 point for this part.
Right, because you got that kind of curve out on those tracks there. Okay.
Correct.
All right.
Correct.
Wow. Okay, so it knows where the corner of this board that you pasted down onto the spoiler boards are.
Correct. Correct. So we need to. It's called the model origin or the part origin.
You usually use the lower right.
I normally use the lower left, but it was easier to set this part up to in this orientation specifically, due to material constraints and otherwise. So next we're going to go ahead and probe our Z. So we're also going to go ahead and do our touch detected. And if you want to get a shot of this on the screen, I have to do the lift, touch off, start the probe.
And that's just to set the Z depth?
Correct. So that's setting the height. We have checked the depth of this tool, the thickness of it, with a micrometer. So I know
exactly how far.
Precisely exactly how thick that part is.
Now it looks like it has ridges. Is that from the CNC process?
Correct. When I CNC machine this on my mill, the tool marks here left over are left over from a 2D adaptive tool path with a roughing cutter. Realistically, you're probing this side less often than you would probe the other side, which is a lot smoother surface.
That's a smoother surface?
Correct, yeah.
Oh wow, it's got that, visually it looks like it's got ridges.
Correct, yeah, it has almost nothing perceivable. Checking that with an optical flat, we're looking at 1 to 2 10,000ths of an inch dip maximum across the surface. So we are now touched off. I'm going to go ahead and go over to X0, Y0. We're going to go ahead and precise move down. I'm going to go ahead and pull this button. Oh, I don't have that button on here. Yeah. So we're going to go ahead. The old adage of measure twice, cut once really makes sense on a machine like this. When you have limited material, you're talking about a machine that is going to do movements that you may not have prepared for. You told it to make every move that it's going to in the software, but it might be things you were not expecting. So we're going to go ahead and make sure that we're zeroed off on that origin really nicely. We're going to make sure that we're happy with all of its information. We're going to make sure and verify that we're using the right tool based on what the software is telling us, based on what we've programmed in. So,
and what is the tool you just attached magnetically there?
That is the magnetic dust shoe, as CNC Labs calls it. It's a 3D printed dust collection device. It accepts a vacuum source, whether that be a dust collector, shop vac, or otherwise. and it funnels that suction air down into the bottom and pulls the wood dust, wood chips out of there. Allows us to cut inside, do a lot of filtration on the air.
And that's you're doing like a cyclone air filter there too?
Yeah, cyclone separator. Cutting MDF specifically, you're creating a lot of really fine dust that will clog filters very, very, very quickly. Even if you're using pre-filters, filter bags, and filter media, that clogs really quickly. They're a bit of an inconvenience to clean. They're also expensive to replace as you need. Cyclone separator has no moving parts. It traps about 95% of the dust based on our testing. And
yeah, so your filters last like longer than instantly clogged.
Yeah.
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 All right.
Okay, we're gonna
Fire it up.
thing here. Because it didn't cut all the way.
So that should have been a cut all the way through.
Correct. It's just
Now you let it finish rather than interrupt it, right? So
yeah, well, it would have moved all the way to the corner had it finished following the G-code. It gets out of its own way, so that way you can clear the surface off. It's assuming you've got a part the maximum size. I stopped it from going all the way over there. I stopped it safely using a pause command in which it schedules the stop. Otherwise, if you emergency stop the machine, it doesn't necessarily know exactly where it was when you emergency stopped it. Therefore, you have to re-zero the entire surface from scratch.
So it's still dialed in on exactly where it is.
Correct. So I'm just taking a look at the G-code, kind of seeing what's going on with this cut. It's a really simple cut. It's only, I don't know, 60 lines, something like that. 43 lines of G-code total. I'm just double checking what it's saying.
And do they call it the slicer, making the G-code here?
Yeah, it's our CAD CAM package, specifically Fusion 360. CAM is computer-aided manufacturing. We use it to produce the tool paths and to do the machine simulation.
Right. So you have a graphic interface for designing stuff, and then it kicks this out.
Correct. All a part of the part design. So here, one of the cool things you can see about using the tape and super glue method is we left a little bit of space underneath the tool. We cut all the way through the part. We left a little bit of tape and glue there at the bottom, so we were sure not to touch the bottom of our spoil board. That allows us to cut all the way around the part without any clamps, any screws, any nails.
So do you just file off the rough part, or?
Yeah, this will just literally come off just by rubbing it with your finger.
Oh, nice.
It's leftover wood
It's
dust.
like exactly how deep it needed to be.
Precisely.
Not to, okay.
It's exactly, it's a CNC machine. We can control that. So, and now because we don't need that part anymore.
Yeah, it comes out.
Okay, so now we're going to set up tool number 2. The 2-part job. Luckily, because the machine knows our XY0, which is this corner of the part,
Yep.
we now have to set our Z0 on a separate tool.
Ah, right. It's not going to be the same length.
Correct. As well as this is a really good opportunity to show this XY touch plate can still tell exactly where the corner of that part is, even though the corner is missing entirely.
Gotcha.
It's using the plane.
Yeah,
of
the long
both
sides,
of
yeah.
it.
Yeah.
Positionality is the exact same as what it would have been otherwise.
Okay.
You might want to cut that over when we were talking about the bit earlier.
Gotcha. Okay.
You can only see what it is.
Yeah. So that's going to engrave the pattern.
Yeah. So we'll engrave the text and the pattern and all that stuff with a V bit. And I'll get you a.
So it's tapered. Is it tapered?
Correct.
Okay. Which you don't necessarily want on the one where you're just cutting the sides out. You want it to be a vertical cut.
Correct.
Yeah.
Correct. We're doing shaping initially.
Yeah. Can you turn that a little bit? Yeah.
Let me get this out of your way so you can kind of.
So you're redoing the Z calibration because the tool's a different length.
Yeah, I'm touching off on a Z0. This is technically a separate program from the initial one. We separated by tool for a number of reasons, one of which it's easier to stop when we're not in a rush, we're not in the middle of a program, we're not going to mess anything up. Just be in a position to where we can really take our time and get the tool touched off. That's it.
All right.
So now it knows the length of that tool, and it knows exactly, based on the program, what it needs to cut.
That's really locked in there, so you don't have to worry about handling, messing up the calibration, right?
Correct.
Oh, beautiful.
So this is some of the really great things about CNC cutting is it takes a little bit of extra time, but you get a really great finished product out of it. You can pick your material a lot easier. You can get a lot of control over the accuracy and the dimensions of the part. You get a lot of choice in programming. It takes about 30 to 45 minutes for a part like this.
And it's the replicable if you need to.
Correct. Yeah, you can do mass production on a machine like this fairly easily, fairly quickly. Use the similar methods here. You can consider different work holding as well. And there you are, quick intro to CNC cutting on a CNC Labs LongMill Mark II.
Thank you, Jacob. That was Jacob from Spark Studio Salem Makerspace, a local nonprofit. And you can get some more information about that at sparkstudiosalem.com.